So this is where things actually, this is specifically to grade 11 applied. We do linear inequalities in pre-cal as well, but we use our graphing calculator so we can go a little crazier with the equations we give you. Okay. Linear. So this is page 17. Okay, when dealing with inequalities, right, we use these symbols instead of an equal sign. Okay, so you will not have an equal sign anymore. We'll talk inequalities. Okay. Oh, there it goes. There's the music again. They wait till I talk. An inequality does not only deal with the points located on the line. It deals with the points that are either above or below the line as well. Okay. We indicate this by shading the area or pane above or below what we call the boundary line. Okay. Very important concept. So the inequality, as soon as you see that inequality symbol less than or greater than, right? This inequality would have a boundary line of, watch this, I'm gonna just highlight that this is an inequality, this has the equal sign. So these are somewhat related. This is an inequality where we're interested in the points that are either below or above the line, and this is the line itself. This splits the coordinate plane into two panes, right? So we split, that boundary line will split the coordinate plane into two panes. Okay? In this unit, we will shade using regular or reverse shading. I'm going to highlight regular with one color and reverse with the other. And I will make sure I do that here too. Regular versus reverse. Oops. Okay. So here's where you need a ruler perhaps. So let's say we have this boundary line that looks like this. And we're going to make an exact copy of this on the other side because they're basically, it is the same graph. Okay. Okay, so are you ready for this part? This is different. In our intro to applied and pre-cal, only points that were on the line is what we would consider true, and everything outside of it would be false. Those points do not belong. When we do inequalities, we have a true region, so let's say everything above it would be true. So if this is true, that means that this other side would be false. These points would not be applicable. Same with this other. If we're talking about the same inequality, that is still, these are talking exactly the same. They're saying the exact same thing. When we use regular shading, we shade the true region. So let's go ahead and shade the true region. So I use my ruler actually. This is where coloring between the lines comes back. You were always wondering, when am I going to use this ever again, right? Well, here it is. Okay, so we shade. So that's telling us that, right, all the points in the true region are part of the solution. All right, so that's when we use regular shading. If you use something, this is just something that Miss Yosik and me, well, actually Miss Yosik came up with that. I just copied it. Reverse shading is where you shade the false region. So put your ruler on this side and we shade the false region. Now when we shade, we don't make it too dark, right? Just go a light shade so you can still see what's labeled, the points that are there, okay? So watch this, the true region, I'm going to circle it with a different color because that's the true region has never changed. True region still remains exactly where it's supposed to. It's just that we're shading the false region. And before you wonder, why in the world would you do that? Why wouldn't you just stick with the textbook? Why would you introduce a reverse shading method? This is why. Can you imagine having 3 different inequalities and you're shading away, and one shaded area will overlap with the other one and so forth? And you're going to wonder, okay, which one is my solution now? Like, I see 2 overlapping here, 3 overlapping there. Like, it's so hard to see the solution. If you shade the false and leave the true area alone, you will clearly see which one is the solution for all of the lines that are there, right? I will show you that later. Right now, you might be a little like, what is he talking about, right? Just follow along and you'll see what I mean. So this is going to be a preferred method, especially when we use multiple inequalities. Okay, this is a disclaimer here. Textbook only uses regular shading, but the true region does not change. True region does not change. It's just what do we shade, that's what changes. So that's one thing that I need you to make a distinction is the regular versus the reverse, but the true region never changes. Next, dashed versus solid boundary lines. I'm going to make these pointing up this way. So there's going to be times where we use a dashed line, and there are times where we use a solid line. And let's say the true region is below the line in this case. And you're like, how do I know? Well, later on, we'll find out exactly that that's the case. So we take our ruler and we just lightly shade the true region. I'll just go quick, like I don't want to spend too much time here. If you want to make it prettier later, that's fine. So watch, when you only see these symbols that do not have the equal sign, right? Then we have a dashed line. What does that mean? It says it right there. Points on line are not included in the solution. So the line is just a boundary line, but if there were the point that lands exactly on the line would not be part of our solution. If you have less than or equal to, greater than or equal to, then we have a solid line. And in this case, points are part of the solution. I'm just going to make this is new. I don't have that on my original, but let's say this point is 0, 2, let's say. We know that one for sure. Same here on the other side, 0, 2. Okay. We know that it's on the line, but this one would not be a solution. Okay. This one is a solution, is a possible point that would be applicable because we're told the line is solid. So anything on the line and below is part of the solution. What kind of shading did we use for these two examples? We shaded the true region for both, right? So we used regular shading. Regular shading. Can you imagine writing this all down by hand? Like every single graph I give you. I used to spend so much time just getting students to write down the notes. That's why I made booklets. I want to get right down to business, not writing down or making graphs. So we got this out of the way, regular versus reverse and dashed versus solid, right? Let's keep going. Top of page 18, rules when working with inequalities. Watch this. When multiplying or dividing inequalities by a negative, maybe underline that, we need to flip the symbol. We need to flip the symbol. What am I talking about, right? So here's an example. Let's say 2 and 5. You would agree that 2 is less than 5, right? That's how you read it, right? 2 is less than 5. That's true. That's a true statement. Let's say, because we can do the same thing to both sides, just like an equation, you can do that with inequalities. Let's say we divide both sides by -1. Okay. What would you end up with? 2 divided by -1 is -2. 5 divided by -1 is -5. If we kept that inequality the same, would that be true? If we kept that less than the same way as it was before, would that be true? It's not true. This is smaller than that. So we need to flip it. I'm going to use different color here. So I'm going to flip that the other way. And I'm just going to say flip sign. Otherwise, statement is false. Okay? You want me to add that? Otherwise, statement is false. I wish I had an animation for that, how it like slowly flips the other way, but we can't do that, right? Like a GIF or something. Here we go. I'm going to give you another example. This is where this is going to happen. Let's say you have something like this. I give you an inequality like that, right? You're like, hey, that kind of looks like an equation, but it has the inequality, so it's an inequality, right? So let's say I want you to rewrite this. So I would say bring the 3x over to the other side. You treat it just like you would an equation. So it's -2y is greater than or equal to, the 3x comes over, positive plus 10. And what would you do next here? You usually divide whatever's in front of y, right? You have to divide by -2 in this case. And this is where it should ring a bell. Oh, we're dividing both sides by negative. Mr. Dirksen told me to flip the sign. So we take the sign, because of what we learned here, we do the same thing here. It's pointing to the right. We're going to make it point the other way. Like that. So we end up with y is equal to -3/2x minus 5. Okay. I wonder if we're going to enter that into our calculator. Yep. Yep. flip, right? This is going to be so important. It doesn't happen very often, but it does happen often enough. Like it does show up on quizzes and tests and ACs, right? So you got to watch out for that. It's a very important concept. Okay, so this is going to be the space is not the greatest here, but I'm going to try my best. Determining the true region or true plane. We're going to use the test point method, and then I'm going to show you a shortcut. Okay, so the graph of the inequality negative 2x plus 4y is less than or equal to 16 is given below. Is this an example of regular or is it an example of reverse shading? How would you even know this, right? At this point, we have no idea. How would you know? Okay, so this is what I'm going to ask you to do. Pick a test point. Oops. Pick a test point. Okay. Watch this. I will pick, which point do you think teachers, in grade 10, they told you to pick a point that would be the smartest point to pick if you ever had to pick one, the easiest one to work with? Anybody? If you had to pick any point in this graph, which one would you pick? 0, 0. There we go. Because it's the easiest, right? I'm going to pick this one. 0, 0. Yes, I pick 0, 0. Yeah. So I'm going to plug this point into this inequality and see what happens. All right. So let's anybody in computer programming, true and false is a thing, right? It's basically the same thing here. Minus 2 times 0. Hey, that's going to be 0. I like that. Plus 4 times 0 is less than or equal to 16. So you're just plugging in and checking. Okay. What would this side equal to? This is 0 and this 0 is just 0. 0 is less than 16. Ask yourself the question, is this true? I think we would all agree yes, right? This is true. So when you're supposed to check, just plug in and see what happens. Okay? So follow my logic here, guys. If this point is in the shaded region, and I just figured out that it is true, right? This point right here is true. I can now conclude that the shaded region, everything in here is true. You just have to pick one point in here. You plug it in and see if it's true or false. If this had been false, like if us plugging in the 0, 0 would have resulted in false, we would have said, okay, this whole region is false, right? But because it's true, we conclude that, let's make it nice and big here, true region. True region. I'm not going to do arrows yet because I want to make sure I don't use up too much space. But I might later on say, hey, this is why we did that. So what kind of shading is this? What region has been shaded? True region, right? This is regular shading. I know you're like, I don't really, I sort of get it, right? But just follow me for now. So I figured out, I picked a point, which was 0, 0, conveniently located, and I figured out that it is true. That point is true, so everything is true. So regular shading. Comma, since the true region is shaded. A lot of shady things happening here, right? That's why you shouldn't trust trees, right? They're too shady. Yeah, I tried. I want to make sure you want to go into grade 12. You don't want to stick around too long. All right. This is the shortcut. We're going to use the shortcut way more than the test point. Okay. Shortcut. Rewrite into y mx plus b. And the reason why I don't put an equal sign there is because it could be a less than, a greater than, it doesn't matter. So let's just leave that blank like that. You see how the space, yeah, I made a note for myself, but I forgot to actually do it. My bad. So let's take this. So I'm going to go 4y is less than the 2x that comes over adding plus 16. I'm just going to make an arrow here. Right, I brought the 2x over to the other side of that symbol and it changes sign, therefore. It's like adding 2 to both sides, right? Same thing. Now I'm going to divide both sides by 4. Do I need to flip the sign? I don't because it's not a negative. I'm not dividing by a negative. That's the only rule. It's only when it's a negative that the rule applies. So y is less than 2 over 4 is a half, right? You would agree with me there? Plus 4. Okay? And this is the shortcut. Y less than, right, means the true region is below the boundary line. I'm going to put this in like a cloud. Make sure you write that down. I'm going to highlight that as well. Y less than means that the true region is below the boundary line. So what would y greater than mean if you end up with y greater than? Yeah, the true region is above the line. Yes. What am I focusing on? Am I focusing on the false region, guys? Nope. I'm focusing on the true region. Okay. So if this is true, that means that everything above here is false. Okay, I'm going to write that smaller because it's false, right? So I hope you understand that if you look at the line itself, right, anything above it would be here and anything below it would be this way. Same if it's pointing the other way. There's always an above and below, right? So make sure you understand that. And it's a little crowded, but here's the summary that I'm going to give you. This is the summary. Okay, so let me just make sure I get this right here. Yeah, okay. So if you have y is less than or y is less than or equal to, the true region is below. If you rewrite, if you isolate, that's important, and you get y is greater than or y is greater than or equal to, the true region is above. I will highlight true region because it's so important. Okay, and this is what I usually do. This is my code. True is below, and true is above. That's my code for me to quickly know where the true region is. Okay. And so I'm going to give you two graphs here side by side. Don't use a ruler, just wing it, okay? So let's assume this is our small little graph here, and you have that boundary line. You have that boundary line. It's a solid line in this case, right? But if you end up with this, y is less than or equal to, you know that the true region will be here. I'm not going to shade, I'm just going to tell you where the true region is. At the same time, let's make a line that's dashed and it's going down like this. Some students have a hard time of figuring out above or below. I don't know how to explain it, but right, this would be below. This would be below. So I would put the true region here in that case. Okay, and I'm going to focus on true. And then you have when it's greater than or equal to, or just greater than, I'm going to copy this line here. I'm keeping you busy, right, with the different colors. I'm going to make the dashed line here. Just so you know, I'm going back and forth between solid and dashed just to make you realize that it will be one or the other. It doesn't always have to be solid. So if it's like this, if you isolate and you see that, the true will be above the line. Okay. And this one here, we haven't dealt with this yet, but when you only have x, then it's either right or left. So if it's x is less than, then it's left. And if it's greater than, it's the true region is going to be to the right. So true is to the left, or true is to the right. Okay. I'll just make one graph here for both of them. I don't think you need the graphs for your study sheet, but I would definitely have the two top rows here on my study sheet. Okay. So if it's a vertical line, right? So if it's x, if you isolate and you get x is less than, the true region is going to be to the left. And if it's greater than, the true region is going to be everything to the right. I will just do this here. A little note I made to myself after I went through this. So this would be diagonal or horizontal lines. Okay. This is obviously just vertical lines. So if you only have an x, it's a straight vertical. If you only have a y, then it's just a horizontal like this, going side to side. If both x and y occur, then you have a diagonal. Okay. So I'm a little pressed on time, guys, but I think we're gonna make it. Come with me. Let's graph one. Let's just graph it for now. For each of the following, determine the intercepts, rewrite, and then graph. Okay, let's do it. The intercepts. Watch this, watch carefully and listen to how I explain this. I'm going to say 4x minus 5 is greater than positive 10. I'm going to bring the 10 over like that. That's how I prefer it stated when I'm trying to find the intercepts. I'm going to make it look like this. Okay, this is what we call the standard form. And then I'm going to look at the x-intercepts and the y-intercepts. I know this will ring a bell, right? This is how I used to do it. And I'm getting you ready for word problems. That's why I do it this way. So can you do a little mind game with me for now? Imagine this is just a linear equation. Just for now, we're just going to focus on the boundary. So it's going to be 4, oh sorry, I forgot the y. 4x minus 5 times 0. Remember, y is equal to 0 when you're finding the x-intercept. That's equal to 10. You're like, equal? There's no equal sign. Just for now, just do that little experiment with me, okay? Then it's 4x is equal to 10 because the 5 0 is gone. Divide both sides by 4. X is equal to 2.5. And then you go 2.50, stated as an x-intercept, okay? It's not an equation, it's a point. Y-intercept, you do the opposite. 4 times 0 minus 5y is equal to 10. This equal sign stays in here, guys. We do not use it anymore later, okay? So this would be negative 5y is equal to 10. Y is equal to negative 2. So 0, negative 2. Boom, you're done the intercepts. I allow you to skip this first line for both of them next time, okay? Inserting the 0, you don't have to do that. You just go straight to this point here. Let's rewrite. Rewrite inequality, okay? So I'm going to start with 4x minus 5y is greater than 10. Hold your horses, Mr. Dirksen. We haven't done this before, remember? Okay, got it. You're here, right? So I'm going to bring the 4x over to this side. So negative 5y is greater than, the 4x comes over, subtracting negative 4x plus 10. It's getting serious now. Okay, we have to divide by negative 5. Warning, warning, dividing by negative, right? Flipping the sign, engaged, right? So you flip the sign. Negative 4 over negative 5 is 4 over 5. X minus 2. Perfect. That's how you want it. Later on, we're going to graph it with our calculator when we have more than one. But this is the important part here. This is where things are different. Where's the true region? Less than. You can peek if you want. It's below. Less than, I'm thinking below, right? So I do this for myself. True is below. We're going to shade Which shading are we told to use here? We use regular shading. So I want to shade the same area that my true region is in. So I'm going to match it. I'm going to shade, later on, I'm just calling this S. So true is down, shade is down. You want to match it if it's regular. If it's reverse shading, you're going to go the exact opposite. I forgot something before I do this. Is this a solid or a dashed line? Dashed. There we go. Thank you. So I tell myself whether or not it's solid or dashed. I tell myself where the true region is. Why? I know it. Y is less than. I know the true region is below. And I'm shading below because it's regular. Okay? Now we're ready to graph. Let's go up here. Hey, Mr. Dirksen gave us a grid. Thank you. Appreciate that. It's just a copy and paste for me, right? Go ahead, Chloe. So then it's 2.5. 2.5 is right there. 0, -2 is right there. Common mistake right here is you just go solid line because you're used to solid lines. If that happens to you, watch. If you do this, you're like, oh no, it's supposed to be solid, right? That's why you have that eraser, right? You just make a couple of, erase it, now it's dashed, all good, right? Let's see. And then I go to the very tip of it, and I go like that. I put this here. And where's the true region? I'm going to go back here. True is below the line. Where is below the line? Well, I would say this is up here. This is down. So this would be the true region. Make sure you label it. So if this is true, what is this? False, right? Yeah. You don't have to. I honestly want you to focus on the true region. You grab your ruler. If this had been reverse shading, we would have done the exact opposite, right, guys? We would have done this and then shaded this region, but we're using regular shading. So you know what? If you tell me where the true region is, I frankly don't care if you use regular, or some students are rebels and they want to stick with true. Sure, as long as you tell me where the true region is, I'm fine with that. That is a graph. But don't get too comfortable because we're going to do 2 or 3 at the same time. Okay. I'm not quite done yet. I will skip the 2 questions that come down there. We're going to talk about that when we come back. Come with me. I want you to be able to do it the other way. Go to page 21. This is going from the graph and actually writing the inequality that made that graph. It's actually not that bad. This is a lot quicker. These are the steps that I suggest. Determine the slope. I feel like I should have told you and intercept. And y-intercept. Okay, find the y-intercept as well. Determine the slope and the y-intercept. That's my bad. I should have added that. Determine the true region. Is the line solid or dashed? And then just write it out like this. This is your end result right here. Symbol will vary. Okay. So let's do that. Let's find our slope and let's find our y-intercept. You just get it off of the graph, right? There's no other way of doing it. What would be my y-intercept here? We're assuming that if there are no numbers, everything is 1, right? So 1, 2, 3, 4, right? This is 0, 4. So that means that my y-intercept will be 4. Okay. And what's my slope? Notice when I give you a point like that, do you see that point there? use it because I don't want you to guess, right? So we're going to go rise 1, 2, 3, 4. We're going up 4, and we're going 1, 2, 3 sideways. This is my rise, and this is the run. Is the slope going to be positive or negative just by looking at it? We talked about it, right? The 4 slopes. This is going up from left to right, so you will have a positive slope, period. Okay? So this will be 4 over 3. I don't know. I'm going to try here. I'm going to try something. 4 over 3. There you go. Don't mix those up. I see a lot of flipping, like 3 over 4, right? Positive, right? Positive because it's going up. This is just a note that to some students, some will manage with a negative, and I'm like, no, the line is going, if one of the numbers is negative, then the other one should have been negative too. And that's the case. Some students do this. Watch. 1, 2, 3, 4. And then they go back. 1, 2, 3. And they're like, oh, 4 over negative 3. It's negative 4 over negative 3. You still come up with 4 over 3. Okay? So don't get that. Don't mix that up. Here we go. This is a dashed line. So this is step number 1. Actually, I skipped. Where's the true region? Solution, guys, stands for true. So where's the true region when you look at the line? Is it above or below? This is the line. It's going to be below, right? Does that make sense? That it's below? True, below. So I go T down, like that. Third step is it's a solid or dashed. It's dashed. So it'll be this or this. Those are my only 2 options. And then fourth is write out your inequality. So this is how I suggest you do it. Go Y, forget about the symbol, just go 4/3 x plus 4. You got that part right. And now you need to figure out the symbol. True is below. True is below. So you should have y is less than. Does it gonna have an equal sign? Does it have an equal sign as well? And the answer is no, because it's dashed, right? So this, okay, note is wrong, okay? Since line is dashed. Okay. Can you do one on your own just before we leave? Try B. Try to come up with the inequality for B. And I do give you 2 points there. They're somewhat faint, but they are there. You should look at them and use them to come up with your slope. Let's do that. Let's see how you did. And the order doesn't matter to me how you figure this out. Some students can just look at it and then boom, they just write down the inequality. With caution, right? Be careful. And so this would be 1, 2, 3, 4, 5, right? This would be 0, -5 here. So for the first step, if I figure out my slope, I'm going to use this point and this point way over here just to be safe. Okay. So this is 1, 2, 3, 4, 5, right? And this is, that's not a good point, is it? Because it's in between two. I kind of misled you there. Let me try something else. Sorry, I apologize. This is how I do it, and I teach grade 10 like that as well. Scan your line and see if you see a point where it's intersecting right there. I don't know if you see that. That's a pretty good one. And then see if you can replicate that. Watch. I'm going to go 1, 2. Let's get rid of this. I'm going to go 2 and then back 3 and see if I can replicate that. 1, 2, 1, 2, 3. Right? If you can replicate it going up 2 over 3 a couple times and you still land on the line, then you're good. It's blurry, isn't it? So I'm going to say 2, 3, 2, 3. I don't know if you were able to do that because this would technically be 5, 6, 7.5, right? You could probably still get it. Yeah, it'll be fine. So anyways, I'm going to go rise of 2, run of 3. This is a line that's dropping, so it should be negative. Okay, a negative because my line is dropping. Okay, my y-intercept is -5. So that's step 1. Step 2, the true region is above. Step 3, it's solid. And so you can't see that, can you? And now I'm going to write my inequality. Y is greater than or equal to -2/3 x minus 5. Okay, negative slope, it's equal because it's solid, it's greater than because true is above. Okay, so this is the homework, guys. 23 to 26. I don't expect you to graph every single inequality, I get it, right? But try at least every other one. You will have some horizontal and vertical boundary lines. And I also want you to be able to do this thing, that you read the inequality from the graph, okay? Thank you guys, you were great. I'll see you on Monday.